Hi guys, happy Sunday. Welcome to Basic Bit. Today we're going to be working on a binary tree problem called Populating Next Right Pointer. So given a binary tree that contains a value, a left node, a right node, and a next pointer, we want to populate this tree with the correct next pointer. So in the example given here, in each level, if there is no node to the right, the next pointer should be set to null. But if there is a node to the right, so 3 is to the right of 2, there should be a pointer from 2 to 3. If there's any missing nodes, for example, 3 doesn't have a left node, so the next pointer of 5 should point to 7. My first thought is that this problem looks very similar to level order traversal of a binary tree. For example, in level order traversal, we would want to print out the elements of these nodes level by level. So that we would want 1, and then the second row 2, 3, and then the third row 4, 5, 7. Level order traversal can be implemented using a queue. So for example, we initialize the queue with the root element 1. And then we can have a while loop that pops off the first element from the queue and prints it out. So it's popped off from the queue, printed out, and then we take this element and we check to see if it has a left child, and if it does, we add that node to the queue, and then we check to see if it has a right child, and if it does, we add it to the queue. And then we pop off the next element and print it, and we can check to see if it has a left child, which it does, and a right child. And then we continue, pop off 3, print it. 3 does not have a left child, but it does have a right child, so we go ahead and add that to the queue. 4 does not, then we pop off 4, print it, doesn't have any children, and similarly we pop 5, and finally 7. So that's how we would get level order traversal of a binary tree. Right here, we're starting out with the implementation for doing level order traversal of a binary tree. So if it's an empty tree, if root is none, then we're just going to return none. Otherwise, we're going to initialize a queue which contains the root node. And as long as there's an element in the queue, we're going to pop off the first element, print its value, and then we're going to check to see if the node has a left node and if the current node has a right node. And if they do, they're appended to the queue as well. And we can see if we run this that that's going to produce the level order traversal of the binary tree. You can see in the standard out 1, 2, 3, 4, 5, 7. Now, in order to solve this problem where we want to add next pointers to in between the nodes of each level of a binary tree, we need to keep additional information. We need to keep track of which level a node is in, and we would only add a next pointer between 2 nodes if they were on the same level. We can keep track of that information in the queue. Basically, we can call the root level to be 0. And in the queue, instead of just storing nodes, we can store a tuple of a root and a level value. So then when we pop, we would not just be getting current, but we would also be getting the current level. And here we need to change this to a tuple as well. And so the left node of the current node should have a level 1 more than the current level. So level plus 1. Let's print it out just to make sure we're doing it correctly. So we're going to print out the value of the current node and its level. Let's run this. All right, so we can see right here in the standard out, we have level 0, level 1, and then level 2. So that looks correct. And essentially, at each of these nodes, we're going to look at the next node. And if the next node is at the same level, then we want to create a pointer. So for example, right here, when we're looking at the node that contains 2, the next node contains 3, it's at the same level. They're both at level 1. So we would want to create a pointer from 2 to 3. But then from 3 to 4, 3 is at level 1, but 4 is at level 2. So we don't need to create a next pointer. We can comment out this print statement, and instead of printing out the node, we're gonna want to check to see if we create a next pointer. So for the current node, if it has a potential next value, the queue is going to contain that next value as the next first element. So after you pop off the first element of the queue and put that in current, if queue is still not empty, so if queue, we then check the new first element in the queue. So we call that next node and next level. And that would be the first element in the queue. We check to see if next level is equal to the current level, and if it is, current.next is the next node. And now we can return the root. Let's run this and see what we get. Okay, so the answers look good. Let's submit. And accepted.